I'm Nikita, and today we are going to solve few problems from the tutorial. So the first problem that we have is the joint distribution of random variables x1, x2 and x3, each taking values in 0, 1 is uniform with joint PMF denoted as fx1, x2 and x3. So it is given that we have three random variables x1, x2 and x3, and it says each of them are taking values in 0, 1 and it is uniform. So what does it mean? It means that each of them, so x1 is taking the value in 0, 1, x2 is taking the value in 0, 1 and x3 is taking the value in 0, 1. So what all are the possible cases that we can have? So let's draw the table. So we have x1, x2, x3. So if x1 is taking the value 0, x2 can also take the value 0, x3 can also take the value 0. Similarly, x1 0, x2 0, x3 1, x1 0, x2 1, x3 0, x1 0, x2 1, x3 1, x1 1, x2 0, x3 0, x1 1, x2 0 and x3 1. Again we can have x1 1, x2 1 and x3 0 and x1 1, x2 1 and x3 1. So these are the possibilities that x1, x2, x3 can have. Means x1 can take the value 0. So the x1 can take the value 0, x2 can take the value 0 and x3 can take the value 0. This is one possibility. Again similarly we have a total of 8 cases and it says each of them are uniform. Okay, so their joint probability their joint probability is denoted by f of x1, x2, x3. So we have a total of 8 cases and it says it is uniform. So since this is uniform, each of them is going to take the value probability 1 by 8. Each of them will have probability 1 by 8. Okay. Now we have another function g of x1, x2, x3, that is a function of our three random variables x1, x2, x3, and it is denoted by x1, x2 plus 2x3, and we have another function h that is denoted by that is given by 2x1 plus x2. Now we have to find the joint distribution of g and h. So g is given as x1, x2 plus 2x3 x1, x2 plus 2x3 and h is given as 2x1 plus x2 2x1 plus x2. Now we have to find the joint distribution of g and h. So how will we find this? So the same table that we had previously, so that was we had x1, x2, x3, f of x1, x2, x3. There we can have another column that is g and it is given by x1, x2 plus 2x3 and one more column for h that is given by 2x1 plus x2. Now for each of the possible values that x1, x2 and x3 are taking, for each of the cases we will see what all values g and h are going to take. Alright, so this is each of one of them was probability was 1 upon 8. Alright, so what is G? That is x1, x2 plus 2x3. So given x1 is taking value 0, x2 0, so and x3 equals 0, so G is going to take the value as 0. For the second case, we have 2 times 1, that is 2. The third one we are going to have again 0. For the fourth case, we are going to have 2. This is going to be 0. This is going to be 2. This is going to be 1. And this is going to be 3. So as we can see, G is taking the value again 0, 1, 2 and 3. Now let's see what all values H is taking. So H is defined as 2x1 plus x2. So 2x1 plus x2, it is 0. Again it is 0. This 1, this 1. It is 2. This is again 2. This is 3. And this is 3. So similarly, H is also taking the value 0, 1, 2 and 3. So if I ask you, what is the range of G? Okay, what is the range of G? So range of G is, what is the range of G? So range of G is going to be 0, 1, 2 and 3. What is the range of H? So again, range of H is 0, 1, 2, 3. Now, what is the probability that G is taking the value 0? So, as you can see that G is taking the value 0 for this case, the first case, the third case, and the fifth one, right? So, for 0, 0, 0, for 0, 1, 0 and for 1, 0, 0, G is taking the value 0. So the probabilities are going to be, we'll have to add these 3 probabilities. So we'll have 3 upon 8. Now what is the range of, now what is the probability that G is taking the value 1? So as we can see, we have 1 only in one case. So this one. So the probability is going to be 1 upon 8. What is the, similarly for 2, it is going to be 1 upon 8 plus 1 upon 8 plus 1 upon 8. So again it is 3 upon 8. And this is again 1 by 8. Similarly you can find for H. So it is going to be 2 by 8, it is 2 by 8, it is 2 by 8 and it is 2 by 8. So what we have to find here is, we'll have to find what is the joint probability of G and H. So we can make the table, the joint distribution table. So G here, H here. So G is taking the value 0, 1, 2 and 3. H is taking the value 0, 1, 2 and 3. So what is the probability that G is taking the value 0 and H is taking the value 0? So as you can see that this is happening in only one of the case, right? The first one. So if you look at the first one, in this case you have G equals 0 and H equals 0. So this is going to be 1 upon 8. What is the probability that G is taking the value 1 and H is taking the value 0? So G is taking the value 1 and H is taking the value 0. This is again 0, right? Now what is the probability that G is taking the value 2 and H is taking the value 0? G2 and H 0. G2 and H 0. So this is again 1 upon 8. 3, 0, it is 0. Now 0, 1. So G should be 0 and H should be 1. So it is again just 1. So 1 upon 8. 1, 1, it is 0. 2, 1, it's going to be 1 upon 8. 3, 1, it's going to be 0. What is 0, 2? So 0, 2 is again 1 upon 8. 1, 2, 1, 2 is 0. 2, 2 is 1 upon 8, and 3, 2 is again 0. So you can see 3, 3 is 1 upon 8. 0, 3 is 0. 1, 3 is 1 upon 8, and 2, 3 is again 0. So this is going to be our joint distribution of G and H.